Packing efficiency and calculations involving unit cell dimensions. Packing efficiency is the percentage of total space filled by the particles in a crystal lattice. 1. Calculation of packing efficiency in cubic unit cell, simple cubic. In simple cubic unit cell, we have the particles present only at the corners. Thus, suppose the edge length of the unit cell is equal to A and radius of sphere is equal to R. As sphere are touching each other is equal to A is equal to 2R. Number of spheres per unit cell is equal to 1 by 8 into 8 is equal to 1. Volume of sphere is equal to 4 by 3 pi r cube. Volume of cube is equal to a cube is equal to 2r whole cube is equal to 8r cube. Packing efficiency, fraction 4 by 3 pi r cube upon a cube into 100 is equal to 52.4%. So, packing efficiency of simple cubic unit cell is equal to 52.4%. 2. Packing efficiency of face-centered cubic structure, cubic close packing. As the sphere on the face center is touching the spheres at the corners, evidently AC is equal to 4R. But from right angled triangle ABC, AC is equal to under root AB square plus BC square is equal to under root A square plus A square is equal to under root 2A is equal to under root 2A is equal to 4R, or A is equal to 4 by under root 2R. Volume of the unit cell is equal to A cube is equal to 4 by under root 2R cube is equal to 32 by under root 2R cube. Number of spheres in the unit cell is equal to 8 into 1 by 8 plus 6 into 1 by 2 is equal to 4. Volume of 4 spheres is equal to 4 into 4 by 3 pi r cube is equal to 16 by 3 pi r cube. Fraction occupied is equal to 16 pi r cube by 3 upon 32 r cube by under root 2 equal to 0.74, or packing efficiency is equal to 0.74 into 100 is equal to 74%. Thus, the packing efficiency of HCP and CCP structures are 74%. 3. Calculation of packing efficiency of body-centered cubic structure. As the sphere at the body center touches the spheres at the corner, body diagonal AD is equal to 4R. Further face diagonal AC is equal to under root AB square plus BC square is equal to under root A square plus A square is equal to under root 2A, and body diagonal AD is equal to under root AC square plus CD square is equal to under root 2A square plus a square is equal to under root 3a. Thus, under root 3a is equal to 4r, or a is equal to 4r upon under root 3. Volume of the unit cell is equal to a cube is equal to 4r by under root 3 whole cube is equal to 64r cube by 3 under root 3. Number of spheres per unit cell is equal to 8 into 1 by 8 plus 1 is equal to 1 plus 1 is equal to 2. Volume of two spheres is equal to 2 into 4 by 3 pi r cube is equal to 8 by 3 pi r cube. Fraction occupied, packing fraction, is equal to 8 by 3 pi r cube by 64r cube by 3 under root 3 is equal to 0.68, or packing efficiency is equal to 0.68 into 100 is equal to 68%. For cubic crystal of ionic compound, suppose the edge of unit cell is equal to APM. Number of atoms, ions, present per unit cell Z. Atomic molecular mass is equal to M. Volume of unit cell is equal to APM whole cube is equal to 1A into 10 raised to power minus 10 whole cube centimeter cube is equal to a cube into 10 raised to power minus 30 centimeter cube. Density of the unit cell is equal to mass of the unit cell by volume of the unit cell. Mass of the unit cell is equal to number of atoms in unit cell into mass of each atom is equal to Z into M, where M is equal to mass of each atom is equal to atomic mass by Avogadro's number. So, P is equal to Z into M by A cube into N0 into 10 raised to power minus 30 gram per centimeter cube.